This is Geometry, Unit 1, Lesson 5, Construction Techniques. We're going to look at perpendicular lines and angle bisectors today. So we have in our warm-up, points A and B are each at the centers of circles of a radius of AB. So we've talked a lot about how when you have two circles that both have the same radius length, then we know those two circles are congruent to each other. All right, our first question says compare the distance EA to the distance EB. Be prepared to explain your reasoning. So if I look at the distance from E to A, I notice that's a radius for circle A. And then if I look at the distance from E to B, I notice that's a radius for circle B. So since we know the two circles are congruent to each other, then that means that this radius of EA has to be congruent to this radius of EB. All right, so I've typed out my response here. Moving on to the next question. It says compare the distance FA to the distance FB and be prepared to explain your reasoning. So when I'm looking at my two circles again, so I'm looking at FA, I notice that FA is a radius for circle A. And then the other distance was FB. Well, I noticed that FB is a radius for circle B. So I'm pretty sure that FA and FB are going to have to be congruent to each other, equal distances, equal lengths, for pretty much the exact same reasoning we had in the first problem. All right, so moving on to the next problem. It's going to ask you to draw a line EF. So we want to use our tools here. If this purple bar here, if this is what you see on your screen, you just click this little arrow to pop it up. I think I'm going to click on pen. Just checking. Oh no, I do have a line tool. So let's click on that line tool. Okay, and so when I draw my line, I think I'm going to go from E to F. Oh yeah, that's a nice straight line. Okay, so I've got my line going from E to F drawn. The next problem says write a conjecture about its relationship with segment AB. So I have my segment EF, and then I have my segment AB. Well, I noticed that I have my two congruent circles, and E and F were the intersection points, and these are the same kind of movements that we were using when we were constructing those perpendicular bisectors. So I think my conjecture, my hypothesis about EF and how it's related to AB, it sure looks like that's a 90-degree angle right here. And it seems like this point where these two lines cross each other is the midpoint for AB. All right, so I have a few conjectures here. EF is perpendicular to AB. They meet at that 90-degree angle. EF intersects the midpoint of AB. And that means that EF is, in fact, the perpendicular bisector of AB. So this lesson is just about using what we know about the perpendicular bisectors to kind of break it apart and look at how we can use this idea of these congruent circles to find perpendicular lines and also to find bisectors, things that intersect the midpoints. Okay, so on the next task, we have a line L and a point on it that's labeled point C. We want to use our straight edge and compass tools to construct a line that's perpendicular to line L, so meets at a 90-degree angle, and we want it to go through point C. So I'm going to start out with a circle with a center through a point. I'm going to create a circle that is centered at C. It doesn't really matter how big this circle is. It's just that we need to be able to see both of the intersection points of the circle. So I don't want to put, like this would be too big. I need to see where it intersects the line L. All right, so here's my circle. I didn't need that point F. Let me get my circle back on there. And there we go. Okay, so I want to click right here where I'm on one of the intersection points. I'm going to come over here, click on my point tool, and the other intersection point I'm going to click on. So mine labeled them F and G. Okay, whatever yours labeled them is just fine. Now we're going to use this idea of using congruent circles to see if we can come up with a line that goes directly through C. The whole point of us putting a point F and G on here is that now we know that we have an equal distance on either side of point C. From C to F is going to be the same distance as from C to G because it's a radius. So I'm going to come back and I'm going to use the circle tool, right, my compass tool, and I'm going to click on one of these intersection points. I'm going to start with my point F, and I'm going to create a circle that's a little bit bigger than the first one that I made. I can make this one really big if I want to. Really, it just needs to be slightly larger than the one that you made at first. Now, when I make the next circle, I want it to be the same size as the circle that I just created. So if I am trying to make this one the same size, I'm going to use my compass tool. It says select a segment or 2 points for a radius and then the center point. So I'm going to select F and H to make the radius. And then see, I'm moving my circle around. It's congruent to this original one. I'm going to click on point G to put the center of it on G. Now, these two circles, the congruent circles that we just created, they intersect each other in two different places. What I'm going to do next is I'm just going to click on my line tool, and I'm going to select my top intersection point and my bottom intersection point. And this line right here is a line that's perpendicular to line L, and it goes through, it intersects point C. So this is the line that we were asked to construct. Okay, so on the next task, we're going to look at bisecting an angle. So we're still using a lot of the same steps that we used here when we were constructing this perpendicular line, okay? A lot of these same pieces. We're just applying them now to an angle instead. So the first task here asks us to estimate the location of a point D so that angle ABD is approximately congruent to angle CBD. So they're asking us to estimate approximately, if I put a point D on here, somewhere inside of this angle, where would it split this angle into two smaller congruent angles? Basically, where is the middle of this angle? This point is just going to be an estimation point, okay? So we're not really using it for anything. We're going to estimate approximately where you think the middle is. I don't know. It looks like maybe that's the middle. Wherever you estimate it, click on it, and it's going to label it point D. Okay, so estimations are illegal construction moves, right? We're not actually using this point for anything. We're just going to check and use our construction tools to see how close we were able to estimate where point D was supposed to go. Okay, so next task, we're going to use the compass and straight edge tools to create a ray that divides angle CBA into two congruent angles. And then the question that we're going to answer is how close is the ray to going through your point D? Okay, so what we're going to do is we're going to start out just like we did up here on the last task. We're going to construct a circle. This time we're going to center it around the vertex of our angle. So I'm going to click on my circle with a center through a point. I'm going to click on point B to make that the center of my circle. And again, it doesn't really matter how big I make this circle as long as I can see where it intersects both sides of my angle. Like this would be too large, this would be way too large, but pretty much anything smaller than this is just fine as long as we can see where it intersects. I'm going to do mine about this size. Okay. Once again, I think I'm going to make my intersection point be on my angle. So there's my point E. I'm going to come over here and I'm going to get the point tool and I'm going to label the other place where my circle intersects my angle. So I've got a point E and a point F where my first circle intersects both sides of the angle. Well, now I'm going to come over here. I'm going to create a circle that is centered around one of these intersection points. So I'm going to start with point E. Using my circle with center through point tool, I'm just going to make a circle. Again, it doesn't really matter how large we make this circle or how small it is. We just need to be able to see where it's going to intersect the other circle that we put around F. So I like to make it a little bit bigger than where I know halfway is in that angle. Okay, you can even make it go all the way outside of your angle if you want to. All right, I'm going to make mine just probably about, I don't know, about that size. Okay, so when I click, it's going to place another point on here. The placement of this point that I click is not really super important, but we are going to use it. So this point G, we are just going to use it to make sure that the next circle we create is congruent to this one. So I'm going to come and click on my compass tool. I'm going to select E and G to make my radius. And then as I move it around, I'm going to click on point F to place it on that point. All right, so I should be able to see where these two circles are intersecting each other. One here at the top and one here at the bottom. Just like before, I'm going to go get the line tool, and I'm going to construct a line that intersects those 2 points. So when I click, they're labeling it H and I. All right, so this line is the angle bisector. We have split this angle into 2 congruent halves. So the question on our task was, how close is the ray going through your point D? So here's my ray, here's my point D, right? Mine was actually pretty close, I think. I've seen several where, oh, I've got the wrong thing selected. We don't want that. All right. I've seen several where point D is maybe a little bit closer to C or a little bit closer to A. If your point D is anywhere along this line that you've constructed, then you had a pretty good estimation. Okay. So since mine was pretty close, I think we started out somewhere around there. I'm just going to type a little assessment. I'm going to say that my point D was pretty close to the ray I constructed. All right, so this part where it says take turns with your partner, if you are working on this from home, I just want you to, on a sheet of notebook paper maybe, or up here, just practice a couple of times doing your angle bisector. If we do not have a partner, there's probably not going to be much that you are going to have to type in on this task right here. Okay, so I am okay if you skip over this one, as long as you practice actually bisecting some angles. All right, so we have some little optional videos. If you want to watch this video, you absolutely can. You can try this with your own paper at home. It's I think pretty interesting. I'm not great at origami, but I love it. But there's not any part of this right here that you're going to be tested over or anything like that. This is optional here. Okay. All right, I think that's going to do it for the lesson for today. We looked at perpendicular lines, and then we looked at angle bisectors, and really they were following the same kind of process. Okay, make sure you answer the practice problem questions in the Go Formative, and hopefully I will get to see you again soon.